Okay. So first of all, as we have discussed that in your first module, we'll discuss about DC circuit. In your second module, we'll discuss about single phase AC circuit and three phase AC circuit. Okay. And in your third module, we'll discuss about transformer. We'll be having only single phase transformer, not three phase. Okay.
No,
So
sir.
this is your
No, sir.
in your fourth module, we'll discuss about DC machines and motors. And at the fifth module, we'll discuss about electrical installation, how we'll install the devices in your homes. So that will be your fifth module. First module is your DC circuit. So let's discuss about DC circuit. So first let me tell you about some fundamental topics or fundamental elements of the DC circuits. How many basic elements are required to see the a DC circuit? Okay, so let me divide this in two parts. First is how many components are there. Okay, so I will say there are two types of components in your DC circuits. One is your active components, and one you can divide in as a passive component. So from the name itself, you could think about active means which can provide energy to the circuit. Active means the elements which can provide energy to the circuit will be known as active components. And what will be your passive components? Okay, so your active components are divided, actually they are divided in two parts: dependent and independent sources. So here in our syllabus, we are having only independent sources, not dependent sources. Dependent sources is not there in our syllabus. So I'll exclude them. I'll exclude them from these components. I will directly divide your active components at two parts as voltage source and as current source. Okay, so actually these are divided in two parts like dependent sources and independent sources. But here I'm dividing them as voltage source and current source. Okay, and your passive components are having three types. One is as resistance, one is as inductance, and one is as capacitance. Okay, so we'll be having resistance, inductance, and capacitance in case of your passive components. Passive because these components cannot provide the energy to the circuit. They usually, not always, they usually absorb the energy. So that is why they known as passive components. And active component, voltage source, and because these are the sources which provides the energy to the circuit, that is why they called as active components. Now we'll see that voltage source again can be divided in two parts. Can be ideal voltage source and can be practical voltage source. Similarly, your current source can also be divided in two parts. One could be your, you can see, ideal current source and practical current source.
Yes, sir.
Okay, any questions?
Yes, sir.
Okay, so if there is no questions, so let's go ahead with active components first, or we can directly switch to your voltage sources, or you can say we can directly switch to your ideal voltage source and practical voltage source. Okay, so now we'll discuss about voltage source. Voltage source here, as we are discussing about independent voltage source. So you this is nothing but a battery. So the symbol of battery is denoted like this, or it can be denoted like this. So you can see both symbol like this. Now there are two type of voltage sources. One is ideal voltage source and one is practical voltage. Okay, in case of your ideal voltage source, there will be no resistance, or you can say there will be no internal resistance. There will be no internal resistance, or you can say the internal resistance value, the value of this internal resistance small r will be equal to 0. the internal resistance of ideal voltage source will be 0. And in case of practical voltage source, the internal resistance R will be greater than 0. Understood? See, if it is your ideal voltage source, if there is no battery, and if suppose you have connected some load across it, suppose you have connected some load, capital R, load RL, let's take load across it. So what will be the voltage over here? What will be the voltage at the load? What voltage will this battery provide to this source? Can you tell me what will be the voltage? Okay,
Same voltage.
same voltage will be there. Means for any value of this current, which will flow in this circuit, current का value कुछ भी रहे, the voltage is going to be constant, because current का value से यहाँ पे जो voltage drop है, यहाँ पे voltage drop तो होने वाला नहीं है, because R का value यहाँ पे 0, because this R is 0, so the loss in voltage is going to be 0. So जो भी यहाँ पे voltage, जो भी ये voltage है, वही voltage इस point पे भी रहेगा. Voltage at this point, which is your V, is going to be same as voltage at this point. Means the VL is going to be constant for all the time. Now let's take for the practical condition. Okay, in the practical condition, if I'll talk about VL, if I'll connect some load across it, okay, if I'll connect RL over here, so what will be your VL? What will be your VL? This, if I'll write this as VL, because of this battery, there will be some current. This I will be there. Okay, and because of this I and this resistance, there will be some voltage drop across this. Is if I'll write the equation order, don't worry if you're not able to understand this equation, because we are going to discuss how to develop this equation then in very detail. Okay, so if you're not able to understand, that's okay. So here I'm just writing the equation. This is V is equal to I into small r minus I into RL, or you can write this as VL, equal to 0. So from here, if I want to find the value of VL, so VL can be written as V minus I into small r. So now you can think, as this R is greater than equal to 0, or not equal to 0, greater than 0, means let's take this is having some value, suppose 3 ohm. So as this current will increase, the value of voltage at this terminal is going to decrease. You're getting it? So means if I'll draw it like this, so if it is 0, okay, if this R is 0, the VL is going to be constant. But if R is having some value, then as the value of I will increase, the voltage VL will get decreased. And even at some terminal, at some point of current, the voltage across VL will be 0. That's very interesting. You can observe it. You can see this very carefully. Current source. Okay, so again we'll be having two things. One will be your ideal current source, and one will be having practical current source. Okay, in your ideal current source, the symbol of current source is this one. Okay, will denote your current source like this, having value I. Okay, this is your current source. So ideal current source is denoted like this, and practical current source is denoted with current source similar and with internal resistance. Okay, so you can see that यहाँ पे कोई resistance नहीं है, but actually it's not like that. There is resistance which value is infinite. There is resistance, but its value is infinite. So the internal resistance of current source, or you can say the ideal current source is infinite. Here the small r is infinite, and here this r, small r, is having a, you can say, a very large value, but there will be some value. It will, you can say, less than infinite, or you can say a constant value, a constant value. Okay, so this is the main difference between ideal current source and practical current source. If we want to see the effect, what we have to do, let's include one load. To see the load, to see the effect, we'll add the load RL. Okay, so we'll see that what will be the effect of this load, or you can say the this load, or you can say this source on this current. Okay, so if I want to draw this diagram with respect to voltage, what will be the value of this current I? So the value of I, here you can say, here this is open, so यहाँ पे जो भी करंट है सारा का सारा करंट कहां से फ्लो होगा? RL के थ्रू फ्लो होगा. So the IL, the current IL, load current, is going to be constant, whatever voltage is there. For ideal current source, the internal resistance is infinite. Infinite means open circuit. If it is open circuited, means all the current will pass through this load. Means for each and every value of V, यहाँ पे जो है वोल्टेज का कोई भी वैल्यू हो, ये जो करंट है वो हमेशा क्या रहने वाला? लोड करंट इज गोइंग टू बी कांस्टेंट, एंड दैट इज गोइंग टू बी I. Understood now? Now if we see the same condition for your practical case, in the case of practical, which is in which there is some constant value R is there. Now if I'll connect some load, on it, RL, if I'll connecting some load RL on it, and let me assume that there is some voltage V. So with respect to this voltage V, now let's see what will be the current IL. So now you can see, if your voltage V is 0, if voltage V is 0 means if there is no RL, means here will be some no voltage. Or you can say if your V is 0 means if it is your short circuited, सारा का सारा करंट क्या फ्लो होगा? IL will be क्या हो जाएगा? IL will be your I only. See, if your RL is 0 means your V is 0. If you want to make this V 0 means, okay, so if this is short circuited, तो क्या होगा? ये सारा का सारा करंट कहां से फ्लो होगा? शॉर्ट सर्किटेड पाथ से पास होगा. Okay, let me give you one example to understand this. Okay, I'm having some current over here, and I am having two paths. You can think in your way. Like if you want to go somewhere, okay, and there is one path having very bad, you can say, very bad condition of roads. Okay, means having lots of disturbances there, and there is one very smooth path. Very smooth path. So from where you will want to go? From the smooth path. So same happens with current. रेजिस्टेंस क्या काम ही क्या है? ये करंट को स्टॉप करता है, और अगर इसको शॉर्ट सर्किट पाथ मिलेगा, सो इट विल गो फ्रॉम द शॉर्ट सर्किट पाथ. सो अगर यहां पे कभी भी शॉर्ट सर्किट पाथ मिल जाता है तो क्या हो जाता है? सारा का सारा करंट कहां से पास हो जाएगा? शॉर्ट सर्किट पाथ से पास हो जाएगा. देयर विल बी नो करंट पासिंग थ्रू दिस रेजिस्टेंस. अंडरस्टूड? अगर मैंने यहां पे इसको शॉर्ट किया तो सारा का सारा करंट मींस IL will become I. But as will increase the voltage, जैसे जैसे वोल्टेज इंक्रीज होता जाएगा तो क्या होता जाएगा? यहां पे जो करंट है, देखो टोटल करंट तो सेम है, I है. टोटल करंट क्या है? I है. अब ये जो करंट है ये दो पार्ट में डिवाइड होने लगेगा. एक तो करंट IL हो जाएगा, और दूसरा क्या हो जाएगा? V डिवाइडेड बाई स्मॉल r करंट यहां से पास होने लगेगा. तो जैसे जैसे ये V का वैल्यू बढ़ता जाएगा, ये V का वैल्यू बढ़ता जाएगा, यहां पे जो करंट पास होगा, इस इंटरनल रेजिस्टेंस से जो करंट पास होगा, उसका वैल्यू बढ़ता जाएगा. और जैसे जैसे ये वैल्यू बढ़ता जाएगा, आपका IL कम होता जाएगा. बिकॉज देखो यहां पे जो टोटल I है, टोटल I विल बी इज इक्वल टू I विच इज पासिंग थ्रू दिस स्मॉल r, एंड प्लस I विच इज पासिंग थ्रू कैपिटल L, और यू कैन से IL, लोड से जो पास हो रहा है. सो IL जो लोड करंट है वो क्या है? I है minus this IR. This IR कितना होगा? Voltage divided by resistance. You can say V by small r. समझ में आ रहा है क्या? तो जैसे जैसे V का वैल्यू बढ़ता जाएगा, जैसे जैसे V का वैल्यू बढ़ता जाएगा, ये लोड का करंट क्या होता जाएगा? कम होता जाएगा. लोड करंट विल स्टार्ट डिक्रीजिंग जैसे जैसे आपका लोड का वोल्टेज बढ़ता जाए. जैसे जैसे वोल्टेज बढ़ता जाएगा, आपका जो करंट है वो कम होता जाएगा. Don't worry if you're not able to understand, because I'm going little higher as of your level, just make you understand the basic concept of your sources, because in complete entire syllabus we are going to use your sources. That is why I have just gone a little depth of voltage sources. So if you're not able to understand of these, how I have getting this, don't worry about it. No one is going to ask how you are going to get this graph, you can say. Okay, the only thing you just need to remember for everybody, that for ideal current source the internal resistance is infinite, and for practical current source ideal the internal resistance will be having some value, and it is always going to come in parallel. Okay, that's another important thing, that in your current source internal resistance comes in parallel, as compared to you can see in your okay, in your voltage source, internal resistance comes in series. But in your current source, internal resistance comes in parallel. That's the important point you need to remember. Passive elements will be having resistance, will be having inductance, and will be having capacitance. Okay, so I'm not going to in much detail about your resistance, inductance, and capacitance, because as these are not in your syllabus, that how they actually became resistance, inductance, and capacitance. So I will just tell you the equations which we are going to use for your resistance, inductance, and capacitance. Okay, so for resistance, the voltage equation for resistance will be given by I into R. Okay, we'll discuss this, how we have got this equation. It comes from the Ohm's law. In the next lecture we'll discuss this equation in much detail. Okay, and the same way, if you want to find current from this, we can write this as V by R. Okay, for inductance and capacitance will come in your second module, in your AC circuit, because for DC circuit, inductance and capacitance will have no one. Okay, because these are the memory element. Okay, so we'll see actually in these two in your second module in detail. Okay, but here I'm just giving you the equations. Here the voltage of inductor is given by L di by dt. Okay, and the current of the inductor will be given by 1 by L integration of V dt. Okay, I'm not giving you the complete explanation of this, so don't worry about it, because it's going to be very easy when you will see in your second module. Okay, so for your capacitor, the voltage is given by 1 by C I dt, and the current in your capacitor is given by C dV by dt. Okay, so these are the you can say the current and voltage equation in case of passive elements. So you should be having an idea about these elements. So if you don't know the symbol of these elements, let me just give you the symbol. The symbol of this element, resistance, is shown like this. The inductance is, okay, symbolic representation of inductance is this, and the symbolic representation of capacitance is this. Okay, so this is your resistance, this is your inductance, and this is your capacitance.